Okay, so today we're going to discuss the quiz questions that we did last week. So we have all together 7 questions. Okay, 7 questions all together, and then this is the marks allocated for each questions. Okay, there's some changes to your exam. Okay, previously you have 10 questions, and all together it should be 100 marks. This time you will have 10 questions all together is 80 marks. So the allocations for the allocations of the marks for each question is okay. Now let's see. For questions 1, now this one, questions 1 is coming from chapter 1. In your exam, is going to contribute 10 marks towards your final exam. Okay, that is a new score. And then for questions 2, coming from chapter 2, 3 marks. And then chapter 3, coming from questions 3 coming from chapter 3 is going to contribute 12 marks towards your final exam. And then, okay, and then the questions 4 until 7, which is chapter 5, chapter 6, chapter 7, chapter 8. These 4 chapters, they are going to contribute 10 marks each questions. Okay, 10 marks each questions. So all together, we have 40, 50, 62, 65. Okay, we should have 65 coming from the first 8 chapters. Coming from the first 7 questions, okay, 65 marks, and the full mark is 80 marks only. Okay, full mark is 80 marks for this year exam. So you will have 10 questions where you're going to finish it off within 2 hours. Okay, and it covers the chapter 1 until chapter 11, except chapter 4. Okay, chapter 4, according to the syllabus, it says it comes out as an assignment, therefore it won't come out in your final exam. Oops. Yeah. Okay. So that is the score. Okay, that is the score for each chapter. So now, okay, now let's look at what is the things that you need to know before you answer the questions. So you have a list of selected constant value. Now you need to know which values to be used, because in your test, okay, I've marked a few paper. Now K, okay, K. If you look at the list here, you have 2K. One is called Boltzmann constant, and another one is a constant of proportionality for Coulomb's law. So the ones that you are going to use in your exam is this K. You're looking at Coulomb's law. So why you go and choose the Boltzmann constant? What for? All right, so there are a few of you who use Boltzmann constant as a constant value in chapter 1. That is wrong. So you need to know which one, okay, which one to be used in your answer. So in your SEM 2, the one that you're going to use obviously is the speed of light, because you're looking at a physical optic and a geometrical optic, and of course all the charged particles, photon, and so on. So you need the speed of light in vacuum, and then you have this permeability of a free space, mu naught, and then epsilon naught. That is the values, the constant that you're going to use. Now here is in your list of a constant, it says this one is the electron charge magnitude. Now sometimes in the exam they write it as elementary charge magnitude. Actually they are both the same. Okay, electron charge magnitude, this one 1.6 times 10 to the power of negative 19. This one can also be used for proton. Okay, you can also use it for proton, not just electron, because proton and electron, they both have the same charge. And then the Planck constant, obviously you're going to use it. And then electron mass, neutron mass, proton mass, deuteron mass. Okay, the ones that you don't have in SEM 2, okay, is the molar mass you don't have. Rabi constant, no. Avogadro, you need it in chapter 11. Boltzmann constant, no. Gravitational constant, no. Free for accelerations, well, I think you might need it, but not always. Okay, sometimes you might need it when your charged particles is moving in an equilibrium state. All right, you might need it. Depends on the questions. And then atomic mass unit, which is 1U. So like I told you, 1U at the same time it is equals to 391.5 MeV over C squared. Okay, so that is the value. 1U equals to 1.66 times 10 to the power of negative 27 kg. And at the same time, it is equals to 931.5 MeV over C squared. So that's why you can cancel out the C squared in your calculations. And then yes, you do have 1 EV, which is equals to 1.6 times 10 to the power of negative 19 joule. 1 ATM and the density of water. No, I don't think you need it in SEM 2. So basically, the ones that I highlight here is the values that you are going to use in SEM 2. You might need to use in SEM 2. So remember, okay, especially for K, because you have 2K right here. So the ones that you want to use is Coulomb's law. That is your chapter 1. You don't go and select the Boltzmann constant anymore. All right, now, list of selected formula. List of selected formula, okay, like I told you in the previous quiz, it is always a good idea to split the questions, to split the equations according to the chapter. So from equations 1 until equations 9, this is from your chapter 1. Okay, this is coming from your chapter 1, in which it means you are going to use it in your questions 1. And then from equations 10 until equations 19, that is the equations for your chapter 2, where you're going to use it in your questions 2. All right, and of course, for Q, for these two equations, you need to know which one is for charging and which one is for discharging. There are still some of you who got the wrong equations in your second quiz. Okay, you have made the same mistake since quiz 1. So you need to know which one is for charging, which one is for discharging. Okay, and then from equations 20 until equations 31, that is the equation for chapter 3, where you're going to use it in questions 3. Okay, there's one more thing I want you to take note, which is which equation is for series and which equation is for parallel. For questions 11, 12, 26, and 27. All right, almost half of the class still got it wrong in your second quiz. You don't know how to distinguish which equation belongs to series, which equations belongs to parallel. That is very, very dangerous in your exam. If you got the wrong equations, then basically you're going to get all the sub-questions wrong. Because usually effective resistance will come out as the first question, first sub-question. If first sub-question is already wrong, then you wouldn't be able to solve the remaining questions. Right? And then equations 32 until equations 40, that is the equation for chapter 4. Okay, chapter 4. And sometimes you might need to use it in questions 4. Okay, you might need to use it. Might not. Because why? Because questions 4 is coming from chapter 5. And for chapter 5, you have the equations B right here. So sometimes you might need to calculate magnetic field by using the equation from chapter 4. Okay, you might need to use these 4 equations from chapter 4 before you calculate magnetic flux. So equations 41 until equation 53 is the equation for chapter 5, and you're going to use it for questions 4. All right, you're going to apply the equations of questions 4. And then equations 54 until equation 65. These are the equation for chapter 6, where you're going to use it in questions 5. Okay, where you're going to use it in questions 5. And then equation 66 until equation 70 is the equation for chapter 7. Now, as you can see here, just a few equations right here. Why? Because the important part in chapter 7 is the sign convention. You have to know when to use positive, when to use negative. All right, and then this one, it will come out as your questions 6. Okay, it will come out as your question 6. And then for equation 71 until equation 79, that is the equation from chapter 8. And you are going to use it in your questions 7. Okay, question 7. And then equations 80 until equations 83, that is the equation from chapter 9. Okay, where you're going to use it in questions 8. Now, as you can see here, just a few equations right here, and one equation, the most important equation, is not given. So you have to memorize that equation, which is your Einstein equations. E equals to K max plus W naught. So this one is not given. So you yourself have to know these equations, and then after that, you just play with the equations given from 80 to 83. See what is the equations that should be substituted into this general Einstein equation. All right, in this general Einstein equations. And then equations 84 and equations 85, this is the equation from chapter 10, where you're going to use it in questions 9. Okay, in questions 9. And then the last one is from 86 until 93. That is the equation from chapter 11, where you're going to use it in chapter 10. Okay, you're going to use it in chapter 10. So basically, that is what you should do before you answer the questions. Oh yeah, and one more thing, what is the marks for questions chapter 9, 10, 11? So for chapter 9, okay, for chapter 9, the marks allocated in chapter 9 is 5 marks. Wait, yeah, this chapter 9 here. Okay, the marks allocated in the questions 8 is 5 marks. Questions 9, the mark is 3 marks. And chapter 11, this one, it contributes 7 marks towards your final exam. All right, so 5, 3, 7. That is the marks allocated in each chapter. So chapter 9 and 10 is just a very short question, very short chapter. Chapter 11, you have a 7 marks here. Okay, it's quite a lot as well. So that is the marks allocated in each chapter. And the things that you should do, okay, I would suggest you to do like what I did in this PDF. All right, you draw a line to show that which equations belongs to which chapter. That would help a lot. Okay, that would help a lot in your exam. And of course, in your exam, okay, once you got a paper, once the examiner says, okay, the exam start now, then what you can do, you tear it out. Okay, kamu koyak list of selected formula and list of constant keluar. You tear it out, and then you keep it aside. Letak di tepi while you're answering the questions, so that you don't have to keep flipping your questions book. Okay, kamu tak payah asyik pusing ke depan, belakang untuk cari equations yang Anda nak. Koyak keluar, letak di tepi waktu Anda menjawab soalan. That is the best things to do in your exam. Don't waste time. Okay, don't waste time because you have only 2 hours to answer all 10 questions. All right. So, well, basically that is the intro for today's class, how to use a list of constant value and the list of selected formula, as well as the marks allocated in each chapter. Now, let us go through questions 1. So questions 1, now you are given a figure shows 2-point charge, where Q1 is a negative charge, negative 2 microcoulomb. Q2 is negative 4 microcoulomb. They are placed at a distance 10 cm and 28 cm from point P respectively. Okay, the distance is not in between these 2 charges, but it is a distance from point P, where if you look at the diagram, point P is located at here. Okay, this is your point P. So Q1 is 10 cm from P, Q2 is 28 cm from P. Sketch the directions of electric field strength at point P due to the 2-point charge. Now, how to sketch electric field diagram? Electric field, you can sketch it even though you have just 1 charge. Okay, and in fact, you just need 1 charge. It is unlike force. Force, you need 2 charges in order to identify whether there's a repulsive force or attractive force between 2 charges. If you want to sketch electric field diagram, then there must be a charge at point P. Okay, it won't be just a point without charge. If it is a point without charge, then usually question is asking for electric field. So in this question, what you want is not the force diagram, you want the field diagram. How to sketch the field diagram? Well, basically what you have to do, you just draw a straight line. For me, I will just draw a straight line, okay, joining point P and my charge together, and then I look at what is the charge. Now my Q1 is a negative charge. If it is a negative charge, then the electric field is inwards. Then this electric field should be pointing towards my Q1. So this would be my E1. Okay, this would be my E1. So you repeat the same thing for Q2. Okay, you repeat the same thing for Q2. So this is a line joining Q2 and P together. And if you look at the questions again, Q2 is a negative charge. So negative charge, the electric field is pointing towards the charge. So you have another field pointing towards Q2, and you are going to label it as E2. Now, what if you have positive charge? If you have positive charge, then the arrow will be pointing towards point P, right? then you just keep extrapolate the line and let it comes out from the other side. So that is what you should do if you have a positive charge. So for example, now if this is your point Q, and then this is a positive charge, so what am I doing? I'm going to do a straight line between the charge and the Q. Since it is positive charge, then the line will be pointing towards the Q, right? So once I have this diagram, I just remake a new diagram where this is my point Q, and then I have electric field coming out from the other side. So you see, the directions of the arrow is the same. Okay, just that when it comes to vector diagram, we won't have arrow pointing into the points that we want, into the destination, into the origin. What we have, if you have an arrow pointing towards the origin, then you let it come out from the other side. Okay, you let it come out from the other side. So arrow, both of them, they are pointing to the right. Okay, so that is how you draw it. Now, this is just a bit of revision. All right, so the main focus in this question is this is our diagram. We have the diagram E1 going to the left and E2 going to the right. Now that we have this diagram, what are we going to do? Okay, we are done with questions A. Now we can proceed to questions B. All right, so that is the complete diagram. You got E1 correct, and if you got both correct, then you got the 2 marks here. Okay, D2, because it's based on the diagram. E1 correct, 1 mark, E2 correct, 1 mark. Now, the correct here, it means you must have the correct direction with the correct label. Some of you label as Q1 as Q and Q2. That is wrong. Okay, that is wrong. Because now you are looking at electric field. You should label it as E1 and E2, not Q1, Q2. Okay, not Q1, Q2. Some of you still label it as Q1, Q2. That is wrong. So now let's look at questions B. Questions B determines the magnitude and the direction of the electric field strength at point P. So how to calculate the magnitude? Well, you just calculate the electric field first. Okay. So when it comes to SEM2, when it comes to electric force and electric field, what you should do, step 1, you apply the equation for electric field. Okay, if it asks you to calculate force, then you apply the equation for electric force. So now, since the question is asking for electric field, let's apply the equation for electric field first, before you do resultant and resolving vector. So E1 is equals to KQ1 over R1 squared, right? And then substitute the value. You have 9 times 10 to the power of 9, and then times with the Q1. Now, when it comes to electric field, we substitute Q as a positive value. 2 micro, 2 times 10 to the power of -6. All right. And then over the distance given 10 cm from point P. So 10 times 10 to the power of -2 cm. And don't forget the square. All right, don't forget the square. So if you got it right, then you will get E1 equals to 1.8 times 10 to the power of 6 and C -1. You repeat the same thing for E2. So E2 equals to KQ2 over R2 squared. It is equals to 9 times 10 to the power of 9. And then again, you substitute it as a value without negative sign. Okay, values without negative sign. Over distance should be in SI unit, 28 times 10 to the power of -2 squared. So the answer is 4.59 times 10 to the power of 5 and C -1. Okay, and C -1. So that is how you calculate E1 and E2. So once you have it, now you can proceed to the resultant vector. Since these questions, you don't have to do resolving vector. Okay, you don't have to resolve it. Why? Because both E1 and E2, they are lying on the same line. They are lying on the same horizontal component. Therefore, you don't have to do resolving vector. Straight away, you can proceed to resultant vector. Now, how to calculate resultant vector? If you look at the diagram, my E1 is to the left. Okay, my E1 is to the left. And then my E2 is to the right. So when it comes to resultant vector, you need to take into consideration the direction. So the electric field at point P is equals to, now E1 is to the left. So negative E1 plus E2 is to the right plus positive E2. Okay, so that is your electric field at point P. So it is equals to negative 1.8 times 10 to the power of 6, and then plus 4.59 times 10 to the power of 5. And your final answer would be a negative value, which is negative 1.341 times 10 to the power of 6, and C negative 1. But this is not the final answer yet. Why? Because you have a value with a negative sign. The question is asking for magnitude. When it's asking for magnitude, then you have to state a value without negative sign. You need to rewrite the sentence. You need to rewrite the answer. Okay, you need to rewrite the answer. So E is equals to 1.341 times 10 to the power 6, and C negative 1 to the left. Okay, to the left. Rewrite it in the statement form. That is what you should do. If you leave your answer in a negative value, okay, as a negative value, 1 mark will be deducted. All right, 1 mark will be deducted. So when it comes to this question, okay, if you got E1 correct, then you got 1 mark. Okay, if you got E2 correct, you got another gantian. Okay, means you substitute with the correct value. And then if you know that to the left means negative, to the right means positive, means you got the right concept, K1. And then substitute with the correct value, G1. Final answer without negative sign, JU1. Okay, with the conditions, the unit must be correct. To the left direction, J1. All right, so altogether, this question, it worth 6 marks. Okay, from calculating the magnitude until you get a direction. Altogether, 6 marks. Now, let's look at question C. Okay, let's look at question C now. Question C, it asks you to calculate electric potential. Okay, electric potential. So questions A and questions B, they are about electric field. Okay, so questions C right now is asking for electric potential. Electric potential, the symbol is V equals to KQ over R. And since you're going to calculate the total potential at point P, now, potential is a scalar quantity. Don't give the direction. Don't go and think that, okay, now I have the electric potential to the left, to the right. I need to use positive sign or negative sign. That is totally wrong. Potential is a scalar quantity. So you just add them up. Okay, you just add up the value. So if you look at the diagram, now you have 2 charges. Means that you will have 2 potential at point P. So just V1 plus V2. And then you expand the equation, you will have KQ1 over R1 plus KQ2 over R2. Okay, KQ1 over R1 plus KQ2 over R2. So now substitute the value, you will have 9 times 10 to the power of 9. And now this Q, you need to include its negative sign because you are looking at the scalar quantity, and then negative is part of the scalar quantity, is part of the value. So now it is negative 2 times 10 to the power of negative 6, right? And then over R is still 10 cm. It's still the same, okay? The only difference between questions B and C is the sign convention, okay? It's a sign convention and of course the equation. But the main difference is the sign convention, all right? And then plus 9 times 10 to the power of 9. Again, Q2, you need to include its negative sign. So negative 4 times 10 to the power of negative 6 over 28 times 10 to the power of negative 2. So the final answer you're going to get is a negative value. So negative 3.09 times 10 to the power of 5 volt. So for this question, if you understand the total potential is just equals to V1 plus V2, then you got concept mark 1. Okay, means you understand the concept. Means that you know that it is a scalar quantity. You can just add them up. You don't have to do any other things. And then substitution. If you got both substitutions correct with a negative sign, then you got G1. And then the last one, answer JU1. Okay, the last one, answer JU1. Now, questions D. Okay, questions D. Questions D, it is asking for potential energy. Now, it is asking for potential energy, means that the question is asking for U. And since you are given 2 charges only, so don't go and apply the equation in your list of constant, because the one in your list of constant is for 3 charges, the KQ1, Q2 over R12 plus KQ2, Q3 over R23 plus KQ1, Q3 over R13. By looking at the equations itself, you should know that that equation is for 3 charges. Now you have only 2 charges. So what are you going to do? You just simply apply U equals to KQ1, Q2 over R12. End story. Because you don't have Q3. Your Q3 is equals to 0. All right? So you just apply U equals to KQ1, Q2 over R12. So plug in the value. Now, when it comes to this one, energy is also a scalar quantity. You need to take into consideration the sign convention. So you will have -2 times 10 to the power of -6. And then here would be -4 times 10 to the power of -6. Right? And then over, now this R12 is the distance between Q1 and Q2. From Q1 to point P is 10 cm. From point P to Q2 is 28 cm. Altogether is 38 cm. All right? So 38 cm is 38 times 10 to the power of -2. So the answer would be 0.189 joule. So for these questions, if you got the substitutions correct, G1, final answer with the correct unit, JU1. Okay, JU1. So that is the answer for questions 1. So I give you 2 minutes to go through the answer. Okay, 2 minutes to go through the answer before we proceed to the next question. All right, now let us move on to questions 2. Okay, question 2, just a very short questions. So a 50 microfarad capacitor is discharged. The key words right here is discharged through a 12 kilo ohm resistor. Calculate the time taken for the charge to decrease to 50% of its initial value. Now, this question is being very nice to you. It gives you 50%. So it doesn't matter whether you understand what does it mean by decrease to 50% or not, you can still get the right final answer. Now, decrease to 50%. What does it mean? It means now the remaining charge is 50%. All right. Remember, the equations that we have is Q. Okay, we have equations Q equals to Q naught exponential negative T over RC. That is our equations. The equations right here, this Q, it represents remaining charge. Okay, it represents remaining charge. So what happened is you need to identify what is the remaining charge in our circuit. If it says decrease to 50%, means the remaining is 50%. If it says decrease to 70% of the initial value, then what does it mean? Decrease to 70% means you have 70% remaining charge. But if the question say it decreased by 70%, then the remaining charge is 30%. Okay, so you need to understand what does it mean by, okay, for example, increase to in the charging process. What does it mean by increase to? Increase by. Okay, in the charging process. This is for charging process. For this charging process, you need to understand what is the difference between decrease to and decrease by. Okay, this is for this charging process. So if you say decrease to 30% of its initial value, it means the remaining is 30% of initial value. If we say decrease by 30%, it means you still have 70% remain in the circuit, in the charge, all right? So now these equations, we have Q equals to Q naught exponential negative lambda T over RC. The information given decrease to 50% of its initial value, means that your Q final is equals to 0.5 Q initial. You still have half of the Q remain in the system, all right? So what are we going to do right now? Okay, so well, you can also calculate the time constant first. Why? Because RC right here, it represents time constant, tau equals to RC. So you can calculate tau first. Let's go back to the list of formula. Okay, list of formula given is, okay, it's RC, then it's all right. You can keep it as RC, that is fine. Okay, so we have Q equals to 0.5 Q naught. So 0.5 Q naught equals to Q naught exponential negative T over, now RC, R we have 12 kilo ohm. So 12 times 10 to the power of 3. And then C given 560 micro. So 560 times 10 to the power of negative 6. Right, so that is your equations. Okay, that is your equations. So the reasons why we need Q equals to 0.5 Q naught is so that we can cancel out the Q naught. Okay, cancel out, cancel out. And then you move exponential to the other side, you will get ln 0.5 equals to negative T over, okay, now this RC, if you got it right, you should have 6.72. Okay, 6.72. So, well, eventually you should get T equals to 4.66 seconds. So for these questions, 1 mark is given to here. Okay, if you understand Q is equal to 0.5 Q naught, so it means you understand the concept. And then if you got the substitution for R and C correct with the right power, okay, with the right standard form, then you got Gantian 1 mark. And if everything is okay, you got the right arrangement, another 1 mark for the substitution, and then find the answer with the correct unit. So this is a 4 marks questions, all right? Now, sometimes these 2G, they will combine into 1, okay? These 2G, they will combine into 1. So it could be a 3 or 4 marks question. So that is your questions 2, all right? That is your questions 2. All right, so now let us move on to a questions 3. This is just a very short and simple questions. Let us go through questions 3 right now. Okay, questions 3. Questions 3A. The current in a wire is 2 milliampere. Okay, you are given current. So current is 2 milliampere, and then in times 2 milliseconds, you are given the time as well. So this is your I, this is your T. How much charge flows through the point in this wire? It is asking for total charge flow. Okay, it is asking for total charge flow, which is the Q. Oops. Okay, which is the Q. So questions 1 is just a very short and simple questions. I is just equals to Q over T. You apply the definitions of the current. Rearrange the equations, you have Q equals to IT. Given I is 2 milliampere, 2 times 10 to the power of negative 3. T is 2 millisecond, 2 times 10 to the power of negative 3. And then it is equals to 4 times 10 to the power of negative 6. And the unit is coulomb. Okay, the unit is coulomb. So if you got the substitutions right, you get G1. Final answer with correct unit, JU1. Okay. Questions 2. How many electrons? Now, what is the difference between questions 1 and 2? Questions 1 is the total charge. So let's say now this is your wire. Okay, this is your wire. So inside this wire, there are a lot of charge. So you are calculating Q, which means total charge of all this electron. So now it wants to find out. Now you know that inside this wire, okay, inside this wire from here to here, the charge is equals to Q. The total charge is equals to Q. But now I want to find out how many electrons I have in this wire. Since total charge is the total numbers of electron times the numbers of charge, the charge of the electron. Okay, the numbers of electron times the charge of electron. So now what are we going to do? We are going to find out what is the values of N. How many electrons we have inside the wire. So Q is equals to NE. Q we have 4 times 10 to the power of negative 6 equals to N is the unknown value. E, you can get it from the list of constant. It's either known as electron charge magnitude or elementary charge. So E is 1.6 times 10 to the power of negative 19. Rearrange the equations. You will then get 2.5 times 10 to the power of 13. And don't forget the unit. Quite a lot of you didn't write down the unit. This N is what? It is the numbers of electrons. You need to tell the reader. Otherwise, how do I know that this 2.5 times 10 to the power of 13 is the numbers of electrons? I don't know if you just simply give me a value without unit. So in this case, in these questions, if you got the substitutions correct, you got G1. And then you got the value with electron, with the unit, then you get another JU1. Okay, you get another JU1. You cannot just leave it as a value without any unit. Okay, otherwise the examiner, they won't know. What is it for? What is the meaning of this N? All right. So that is your questions 3A. Okay, now you just focus on the explanation because we are going to do it as part of the revision as well. This one, the explanations, I will post in YouTube afterward. Okay, so you can copy the solutions later on. Tak payah rushing untuk salin sekarang dan tak dengar apa-apa. Sekarang focus on explanation, focus on the technique, how to answer your exam questions. Okay, the techniques in answering your exam questions, how to score full marks. Why a lot of you didn't get full marks? Why? Because you miss out 1 or 2 steps, because you got the wrong idea, because of the way you write your answer. All right. So right now you focus on the technique menjawab soalan and also the explanation. So now questions B. Questions B, an electric conductor has a square. Aha. You have a square cross-sectional area. But when I go through your answer, quite a lot of you give me the area of a circle. Questions tells you it's a square. All right. So an electric conductor has a square cross-sectional area with side 3 mm and length is 15 meters. Side 3 mm. This is a square. So the surface area is 3 times 3 mm, not 3 times 15 meters. Quite a lot of you use 3 times 15. That is wrong. Do you understand what is square? Maksud square. So square means that all 4 sides, they have the same length. So here you have 3 mm, here 3 mm, here 3 mm, and here also 3 mm. So this is your area. Okay, this is your area. So not 3 by 15. All right, quite a lot of you got it wrong because you don't know what is a square cross-sectional area. So the resistance between the ends means the resistance in this conductor is 0.072 ohm. So calculate the resistivity of the material. How to calculate the resistivity? Well, you have just one equation for resistivity. So just apply that equation. Rho equals to RA over L. Okay, rho equals to RA over L. So it is equals to, now given R is 0.072 ohm. And then how about A? So A, I have two 3x3 sides, okay, two 3 mm sides. So it's 3 times 10 to the power of negative 3 times 3 times 10 to the power of negative 3. So this is how you calculate area for a square. Okay. So this is the area of a square. You're not looking at circle, you're not looking at the rectangle, you're looking at square. So over the length given 15 meter, all right? So it is then equals to 4.32 times 10 to the power of negative 8 ohm meter. That is the unit, okay? That is the unit, ohm meter. So these questions, if you got the substitutions correct, then you got G1, final answer with correct unit, JU1. Okay, JU1. Questions B. If power supply of 5 volt is applied between two ends of the wire, determines the current that flows through the conductor. So basically, this question is just a very simple VIR questions. All right, so you have V as a 5 volt. And then from the main questions, R is 0.072 ohm. So V equals to IR, I equals to V over R. All right, so it is equals to, now V given is 5, R given 0.072 ohm. So the answer is 69.44 ampere. That is the current flow in your conductor. So since this is just a very simple questions, okay, so you just you'll be just given 1 mark in this question. Alright, kalau kamu ada soalan yang sangat senang dalam exam macam ini, then you will just get 1 mark for that particular questions. So most of the times, for every solutions, you will get 1 mark for a substitution, 1 mark for the final answer. In some very rare occasions, okay, they will combine substitutions and final answer as one. Okay, dia akan gabungkan, tapi itu jarang berlaku. Now, let's look at questions number 3. How to solve questions number 3. So, if the length of the conductor decrease, what will happen to the resistance in the conductor? Well, you have rho equals to RA over L. If you want to look at the relationship between R and L, then what should you do? You rearrange the equations. Then what you will have is R equals to rho L over A. So from this equation, R is directly proportional to L. Therefore, if L decrease, R also decrease. Okay, R also decrease. So that is the answer for questions number 3. Okay, this is just a very simple question. So you just get 1 mark for it. Because it just asks you what will happen. It didn't ask you to explain. But of course, you need this step in order to identify. But you don't have to show it. Okay, you don't have to show it. Anyway, that is, it would be better if you show it. Okay, it would be better if you shows it. Why? As a reminder for yourself. Especially when you recheck your answer. Bila kamu buat semakan, okay, kalau kamu ada tulis, then you know what are you doing right here. Is there any careless mistake in your solution or not? So even though mark is not given, I strongly encourage you guys to write it down. So for questions 4, if the conductor is replaced with another conductor with higher resistivity, rho, what will happen to the current? So I. Now, first of all, the equations that we have with I is VIR. So we want to see what happens when we have higher resistivity. So from this equation, equations from number 3, we know that R is directly proportional to rho. So when your rho increase, R also increase. And then from equations, I equals to V over R. Okay, if you are using the same power supply, 5-volt power supply, then your I is inversely proportional to R. So therefore, if R increase, okay, if R increase, what happened? It leads to I decrease. Okay, your I decrease as well. So if you got the I decrease, then again, you get 1 mark for the final answer. All right, because it just asks you to state what will happen to the current. So what you have to mention, what you have to write is just either increase or decrease. All right. So that is your questions 4. So 5 marks question. Apparently, this is just a very simple, very short questions if you understand. Okay, if you understand. Now let's look at question C. I'm surprised, I'm shocked. Almost half of the class got it wrong because you don't know how to simplify it. You don't know how to calculate effective resistance. This is the second last week of the semester, and you still don't know how to calculate series parallel, how to solve series parallel question. That is a big shock for me. All right, now let's look at question C. How to answer this question? First, you have to identify where is your power supply. The 12-volt battery is located on the right-hand side. Okay, this is your 12-volt battery. So questions 1, it asks you to calculate equivalent resistance. How are you going to calculate equivalent resistance? You start from the one that's located furthest away from the 12-volt battery. So in this case, it's the 5 ohm resistor. Now that you have this 5 ohm resistor, what you should do, you try to identify the junction that is next to this 5 ohm resistor. The junction that is next to this 5 ohm resistor is here and here. I'm going to call it as junctions A and junctions B. So from A to B, now what am I going to do? I'm going to try to find out how many possible paths that I can use to travel from A to B. The first one, of course, is going to go in through, it's going to pass us through the 5 ohm resistor. And along this orange color path, I have just one resistor. Therefore, I cannot simplify it anymore. That is the simplest form that I can get. So I'm going to leave the 5 ohm resistor as it is. Okay, and then what am I going to do? I'm going to try to see, is there any other way, other path that I can use to travel from A to B? Okay, that I can use to travel from A to B. So obviously, yes, I do. I can travel from A to B through this 7 ohm resistor. All right, so that is my second choice. And again, along this green color path, I have just one resistor. Therefore, I cannot simplify it anymore. That is the simplest form that I can get for that green color path. All right, so before I proceed, I'm going to label it first, okay, to avoid confusions. Label R1, R2, R3, R4. All right, so now that I have orange color path, green color path, is there any other path that I can use to travel from A to B? Obviously, no. Okay, you cannot travel through other junction. Okay, it cannot pass pass through other junction. So meaning that you cannot, dengan elok-elok I guna perkataan cannot. You cannot travel from A to B by using this path. This is wrong. Okay, this is wrong. Why? Because you got another junctions right here. So you cannot travel from A to B through this colorful path. All right, because there's another junctions on the left-hand side. So that is wrong. So now we have two paths, we have two choices that we can use to travel from A to B. So what am I going to do right now? I'm going to combine these two paths. Okay, now that I have the simplest orange color path and the simplest green color path, next step, I'm going to combine the green color and the orange color path together. So how am I going to combine it? The arrangements of R1 and R2, now these two resistors, they are arranged in parallel. Okay, they are arranged in parallel. So I'm going to combine them by using 1 over R12 equals to 1 over R1 plus 1 over R2. All right. So it is equals to 1 over 5 plus 1 over 7. Add them up and rearrange the equations. You should get R12 equals to 2.917 ohm. That is your R12. And after you combine them, this is your R12 now. Okay, this is your R12 right now. So I'm done with A and B. So what am I going to do next? I'm going to identify the next junction. Okay, I'm going to identify the next closest junction. So now I'm done with A and B. Next junction would be point C, this junction. So now I don't need A anymore. Okay, I don't need A anymore. Why? Because now you have just a straight line path. A straight line path without any junction from B to C. So I can travel from B to C by using this orange color path. All right, just now cannot. Why? Just now because at point A there is a junction. But now I simplify them. So this point A is no longer a junction. Okay, point A sudah bukan lagi junction. Sebab saya sudah gabungkan orange color path and the green color path. So point A is no longer acting as a junction. So the closest junctions for R12, okay, the junction that is located on the left-hand side and right-hand side of R12 is junction B and junction C. Now, by looking at this diagram, from B to C, from this orange color path, I have two resistor lying on top of it. I have two resistor lying on the same resistor, on the same path, sorry, on the same path. In which it means I am going to simplify them first. And since they are lying along the same path, then both of them, they are being connected in series because they are lying on the same orange color path. Okay, they are lying on the same orange color path. So now what I'm going to do, R123 is equals to R12 plus R3. I'm going to solve them in the series form. So it is equals to 2.917 plus 5. So R123 is equals to 7.917 ohm. So this is now my R123. Okay, I'm still looking at junction C and B. But now what I did, I already simplified the orange color path. So right now I have only one resistor along the orange color path. So I'm done with the orange color path. Now let's look at the next path. Okay, let's look at the green color path. So I have another choice. I have one more choice where I can use to travel from B to C, which is through this 2 ohm resistor. Okay, which is through this 2 ohm resistor. So right now what happened right here is, okay, this orange color path is already in its simplest form. Green color path is also in its simplest form because you have just one resistor lying on this green color path. So you cannot simplify this path anymore. So orange color, simplest form. Green color, simplest form. What can I do right now? I'm going to combine these two paths. How to combine them? Obviously, now these two paths, they are being arranged in parallel. So 1 over R, now I can call the equivalent right now. Why? Because after I combine them, there's no more resistor. Okay, you will have just one last resistor. So 1 over REQ over 1 over R123 plus 1 over R4. So it is equals to 1 over 7.917 plus 1 over 2. All right, so your R equivalent is equals to 1.597 ohm. So this is now your REQ. Okay, this is now your REQ. So done, okay, because you have just one resistor left in the circuit, so that is your R equivalent. So the marks given in this question is, if you know R1, 2, okay, R1 and R2, they are parallel, then you get 1 mark for the concept. Because you understand, this type of arrangement is a parallel arrangement. And then if you know R1, 2 and R3, they are in series, then you get another concept mark. Okay, because you understand, when they are lying along the same path between two junctions, then they are being connected in series. Then you got another 1 mark. And then if you substitute into the final equation, you got G1 and then final answer with the right unit, JU1. So this is a 4 marks question. Okay, this is a 4 marks question. So that is how you simplify the circuit. And you see, it's very simple. This is actually a bonus mark questions. And I couldn't believe that half of the class got it wrong. All right. So now next, calculate the current. Okay, so you have the R equivalent already. Now you have a V also. So you can proceed to calculate the current by using VIR. So V given 12, I is the ones that we want to calculate, and then R is 1.597. Okay, the total current in the circuit. So I is now equals to 7.514 ampere. So if you got the right substitution, then you got G1, and then this one JU1. So it's very important to get the first questions right. If you got it wrong, like I told you just now, if you got your R equivalent wrong, then your second question is definitely going to be wrong. All right. So even though, well, you don't like to calculate equivalent resistance, you still have to learn it, because without equivalent resistance, you cannot solve the following questions. You need questions 1 to answer questions 2. And if you got questions 1 wrong, then you don't even have to look at questions 2. You're going to get it wrong. All right? Because this value, the 1.597 is coming from your first questions. It's coming from your questions 1. So series and parallel is very important, not just in this chapter, sometimes in chapter 2. You also need the equivalent capacitance in order to calculate the questions, in order to solve the questions. Right? So that is your answer for questions 3. Okay, and that marks the end of questions 3. Okay, so now I give you 2 minutes to go through it before I proceed to questions 4. Okay, we take a short break. Okay, we take a 2 minutes break, so you can you can go to the toilet, have a short break if you want. So we'll continue again at 3 p.m. to finish up questions 4 until question 7. Okay, now let us continue. Questions for chapter 5. Okay, so chapter 5, now how are we going to solve these questions? For A, okay, for A 50 turns coin with cross-sectional area. Now you are given the cross-sectional area, and then you are given the numbers of turns, is placed in a uniform magnetic field of 1.5 T. So these are the values given. Okay, you are given 3 values. Calculate the magnetic flux linkage. Question is asking for magnetic flux linkage, not just magnetic flux. So in the coil, when the plane of the coil makes an angle 60 degrees to the magnetic field. Now it tells you plane and the field, okay? The angles between plane and the field is 60 degrees. Plane is 60 degrees to the field. What does that mean? When it comes to these questions, I would encourage you guys to sketch it out. Why a lot of you got the wrong angle? Because you didn't sketch the diagram. Now, let's say this is your uniform magnetic field. Okay, this is your uniform magnetic field. And then this is your coil. All right, this is your coil. So when you say the plane of the coil, so where is the plane? Now, plane is this surface area. This plane, it makes an angle 60 degrees to the field, means that the angle between the plane and the field is 60 degrees. So which means when it comes to our calculations of magnetic flux linkage, now equations for magnetic flux linkage, capital letter phi equals to NBA cos theta. Okay, where does it come from? It's coming from, now flux linkage is equals to N flux, okay, and phi is equals to NBA cos theta. So that is the difference between capital letter and small letter phi. Small letter phi is just the magnetic flux for 1 turn of coil. Magnetic flux linkage is the total flux. You have to times the numbers of turns. Okay, so NBA cos theta. So in this case, you need theta. So what is theta? Okay, what is this theta? This theta is the angle. Angles between vector A and vector B. So what does it mean by vector A? Vector A is the vector that is perpendicular to the surface area, to the cross-sectional area. So in this case, this would be my vector A. Vector A, and it is perpendicular to the plane. All right, it is perpendicular to the plane. So just now I have B lying horizontally, A perpendicular to the plane, in which it means the angles between A and B right now is 30 degrees. And this 30 degrees is the angles that you're going to use in your calculation. Okay, so we have angle equals to 30 degrees. If you got it right, if you got theta equals to 30 degrees, then you get 1 mark. Because you understand, okay? Because you understand what is theta. What does it mean by theta? It is the angles between vector A and vector B. So calculate the answer right now. Okay, we have flux linkage equals to N is 50, B is 1.5, surface area given 5.8 times 10 to the power of -3, and then cos 30 degrees. So if you got it right, you should get 0.377 Weber. So first mark is given to the angle. If you understand angle is 30 degrees. And then you substitute everything correctly, G1, and at last JU1. So if you got the angle wrong, then G1 is wrong as well. Okay, you are going to get a 0 mark in this question if your angle is wrong. So it's very important to understand what does it mean by this theta. And then now the coil rotates about an axis perpendicular to the uniform field at a constant angular velocity. You're given angular velocity, but now it is not in SI unit. It is 500 revolutions per second. So what is the maximum induced EMF in the coil? Now you are looking at rotating coil. Okay, you're looking at rotating coil. So when it comes to rotating coil, induced EMF is equals to NBA omega sine theta. Now, the first things that you have to know is omega. Omega given is 500 revolution per second. This is not SI unit. Then how are we going to change it into SI unit? The easiest way is to make it into a fraction form. So it is equals to 500 revolution over 1 second. Now, 1 revolution is equals to 2 pi. Okay, 2 pi radian. Therefore, from 500 revolutions, I'm going to change it into radian. It is equals to 500 times 2 pi, and the unit would be in radian over, now I'm going to keep it as second because second is SI unit. So it is actually equals to 1000 pi radian per second. So that is the unit conversions for omega, for angular velocity. And the next important things in the question is, it mentioned maximum induced EMF. Now, go back to the equations. You have an equations with sine theta. So when we talk about maximum, okay, when we talk about maximum value, then we always assume sine theta equals to 1. So in this question, it doesn't matter whether you want to use omega, EMF equals to NBA omega sine theta or NBA omega sine omega t. It won't affect your final answer. Why? Because this part, it would be equals to 1. It doesn't matter whether you're looking at omega t or theta. Okay, it is always equals to 1 when it comes to maximum value. So now that I have all of the information needed, I'm going to substitute into the equations. So EMF maximum is equals to N given 50, A is B, and B 8. So B is a 1.5. A given 5.8 times 10 to the power of negative 3. Omega, I have 1000 pi. Okay, 1000 pi. And then the sine theta, you just substitute it as 1. So the maximum value is equals to 5.25 times 10 to the power of negative 2V. So that is the final answer. So, sorry, not this one. I looked at the wrong one. It should be at 1366.6 volt. If you got it right. So the marks is given to, if you got the right unit conversion, this one you will get J1. If you understand maximum means sine theta equals to 1, then you got another J1 because you got the value, you got the right answer. And then you got the right substitution, you substitute everything correctly. G1, final answer with correct unit, JU1. Okay, JU1. So this is a 4 marks questions B, including the unit conversion. So unit conversion is very important in your exam, right? It shows it, you need to have it right in order to get full marks. So that is your questions for A. How about questions for B? Questions for B, now you have a coil of inductance 300 microhenry. Okay, you have a value, inductance 350 microhenry, carries a current 1.2 ampere. Calculate the amounts of energy in the coil. Okay, these questions, most of you got it right. Why? Because you have just one equations in chapter 5 that can be used to calculate the energy. So B1 U is equals to 1 over 2 Li squared. So substitute the value into the equations, 1 over 2. Now inductance 350 microhenry, 350 times 10 to the power of negative 6. I given 1.2, so 1.2 squared. Energy is equal to 2.52 times 10 to the power of negative 4 joule. So that is your questions B1. If you got it right, then G1, 1 mark for the substitution, and JU1, 1 mark for the final answer with correct unit. How about questions 2? The current in the coil is reduced to 0. Aha! Reduced to 0. That means that is your final current. This is your I final. In which it means the initial current is 1.2 ampere. I initial. In 8 ms. Okay, 8 milliseconds. This is your time. Calculate the induced EMF across the coil. So if you go through the list of formula, straight away you will be able to identify which equation should be used to solve this question. Because there is a change in current. You got initial and final current. So the equations that can be used to solve this question is EMF equals to negative L di over dt. So it is then equals to negative, now 350 micro, 350 times 10 to the power of negative 6 again. What does it mean by di? Di means changes. What does it mean by change? Change means final minus initial. In this case, the final I is 0. 0 minus 1.2 over 8 milliseconds. 8 times 10 to the power of negative 3. So that is how you do the substitution. So plug in everything and then eventually you will get 5.25 times 10 to the power of negative 2 volt. So if you got it right, 1 mark for the substitution and 1 mark for the final answer with correct unit. Okay, so again, 2 marks for these second questions. Now, how to solve questions 3? List 2 factors that determines the self-inductance of a coil. How are we going to identify what is a factor that will affect the values of self-inductance? So by looking at the equations, okay, by looking at the equations, N phi equals to Li. So from here, we know that L is equals to N phi over I. And N phi at the same time, it is equals to N VA cos theta over I. By looking at this equation, okay, it tells you that L, it depends on the first thing. The one in your equation is the A. Okay, the area. What area? The coil's area, because you are looking at the coils. So coil's area. All right, coil's area. And then it depends on B. But then since we want to talk about the physical structure of the coil, remember the things that will affect the value is always the physical structure. So how is it going to affect the B? If you recall, if you remember the things that you learned in chapter 4, then the coil's length is the one that affect the values of the B. Okay, coil's length. And then the numbers of turns, the N right here. So the numbers of turns of the coil. Okay, the numbers of turns in a coil would also affect the values of the inductance. And of course, last one, you have the material. These are the things that will affect the physical structure of the coil, that will change the physical structure of the coil. So always look for the physical structure. Okay, you don't go and think, okay, for example, you say, oh, by changing the I, I'll be able to change the inductance. No. Okay, no. When it comes to capacitance, when it comes to inductance, when it comes to resistance, the things that will affect the value is the physical structure. It's the physical structure of the inductor, capacitor, and resistor. So you don't tell the examiner what happened if you change the I. You don't tell the examiner, oh, you can change the resistance, the inductance, and so on by changing the V, by changing the I. No. Okay, all those, it won't affect the values of the inductance. The only thing is the physical structure, remember. All right, because this concept, okay, the idea is not just for chapter 5, you also have to know how to answer it for chapter 2 and chapter 3. Okay, in chapter 2 and chapter 3, the things that will affect the values of capacitance, resistance, and inductance. It is the physical structure. Okay, it is the physical structure. It has nothing to do with the charge, with the currents, and so on. All right. So quite often students will answer the questions based on the equations in number 2. EMF equals to negative L di over dt. That is wrong. All right. It depends on this equation, and this equation, it tells you what happens to the physical structure of the inductor. So that is your questions number 4. Okay, that is your questions number 4. Now let us look at questions 5. Okay, we are done with questions 4. Now let us proceed to questions 5. Questions 5 is the questions from chapter 6. Okay, now you are given a diagram, and in this diagram, you have R, C, and L. So this is the RCL circuit, obviously. So figure 3 shows an AC source, V equals to 156 sine 120 pi t. You are given an equations. Remember the things that I told you before? Whenever you are given an equations, the things that you should do is always compared with the general equations. So you have V equals to 156 sine 120 pi t. Now, according to the question, this V, it belongs to the source. So it's actually your Vs. Okay, it's actually your Vs. So compare with general equation, Vs is equals to V naught S sine omega t. So by comparison, you have V naught for source, which is equals to 156 volt, and then omega equals to 120 pi radian per second. That is the things that you should do before you answer the questions, so that you know what is the information that you have right now. Without doing the comparisons, sometimes you will lost because you can't see it. Okay, kamu tak nampak apa yang berlaku, kamu tak nampak apakah nilai yang diberi. So buat perbandingan dulu, list out the information. Okay, and then from there, you then try to answer the questions given. So it is connected to a 65 millihenry inductor, AC ammeter, 10 ohm resistor, and 35 microfarad capacitor. So you are given L, R, and C. Okay, you are given L, R, and C. So sketch a graph of AC voltage against time. So you want to sketch a graph. How to sketch the graph? And look at the question. It asks you to label peak voltage and period, in which it means you have to calculate the period in order to answer questions 1. So how to calculate period? Okay, how to calculate period? That is the questions. So we know that omega equals to 2 pi over t. Rearrange the equations. You got t equals to 2 pi over omega. Right? So substitute the values into the equations, and you should obtain period is equals to 0.017 second. That is the period. And then peak value, peak voltage. Do you have peak voltage? Yes, you do. You got it by comparison. So 156 volt. So we have the values needed. Now let us proceed to sketch the graph. It is asking for AC voltage against time. So voltage would be your y-axis. Okay, so voltage, and then the x-axis will be the time. How to sketch the diagram? Okay, you look at the equations given. You are given an equations without initial phase angle. And then you have a sine function. Okay, you have a sine function. So you just sketch the sine graph right here. So start from 0, you sketch the sine graph. Okay, you sketch the sine graph. And then after you sketch the graph, of course, you need to label it. So peak voltage, this is the peak value. Peak value given 156. And then here you have negative 156. And here's 0. And then it asks you to label period as well. So period is the time taken to complete one cycle. Here is the period. So value is 0.017. So if you got it right, okay, the first mark is given to if you got all these values correct. Okay, you got D1. Second mark is given to the shape. If you got the right shape, then you got another 1 mark. So full marks for questions 1 is 2 marks. All right, D2. It's based on the diagram, whether you got the correct label or not, whether you got the right shape or not. Okay, so that is your questions 1. Questions 2, sketch Phasor diagram of the circuit. So how to sketch the Phasor diagram? You have the RCL circuit. So you need to sketch for RCL. So when it comes to these questions, okay, so we have I. We always take I as our reference position, our reference vector, our reference Phasor. So since you have R, so we know that for VR, it is always in phase to I. So this would be your VR. And then for inductor VL, it always leads I. So VL is pointing upwards. And then VC, it always lags behind. So VC going downwards. So that is your Phasor diagram. If you got it right, then you got 1 mark. Okay, you got 1 mark. Now, of course, if you don't want to sketch this diagram, okay, because if you look at this question, actually you are not given any information about the V, okay? Rather, you are given the information of inductance, capacitance, and resistance. So sometimes, okay, sometimes students, they might sketch this one. All right, again, you are going to use I as the reference positions. And then you have R and then XL upwards or XC downwards. Okay, and XC downwards. So either one, okay, you give either one is fine. So it's either the one in the green color or the one in the blue color. Okay, so if you got it right, then you got 1 mark. Okay, you got 1 mark for the Phasor diagram. Okay, next, calculate impedance. So how to calculate impedance? Let's see. So question 3, calculate impedance. Now, since you are given RCL circuit, right? So what are we going to do? We are going to calculate XC, XL, and R. Okay, we are going to calculate these 3 quantities. So before that, since we are given omega, so let us calculate the F first. So F equals to omega over 2 pi, which is equals to 120 pi over 2 pi, which is then equals to, which is then equals to 60 hertz. Okay, 60 hertz. And then calculate XC. XC is equals to 1 over 2 pi FC. Plug in the value, 1 over 2 pi F is 60. And then capacitance given is 35 times 10 to the power of negative 6. So if you got it right, then your XC would be equals to 75.79 ohm. XL is equals to 2 pi FL. So 2 pi 60, L given 65 times 10 to the power of negative 3. So if you got it right, you should get 24. Okay, 24.5 ohm. So that is the answer. Now, of course, some of you use 1 over omega C and then omega L. Also can, okay, also can. Nothing's wrong with that. So once you have it, okay, you can then calculate the impedance. Z is equals to square root. Now, the one line on the X component is XL and XC. Okay, and then for X component, we have just R. So this one would be R squared plus XL going up, so XL minus XC squared. Okay, so what are you going to do next? Just plug in the value. Okay, plug in the value. Square root. Given R is 10 ohm, so 10 squared plus XL is a 24. So 24.5 minus 75.79. Now, it doesn't matter whether you want to use XL minus XC or XC minus XL. Why? Because you have a square right here. So eventually, you will get a positive value. Okay? You will get a positive value. So Z is equals to 52.25 ohm. So for this question, the first mark is given to the frequency. All right. Now, if you didn't use frequency, if you straight away use omega, then we are going to assume you got the right answer. Okay, kalau kamu terus pakai XC equals to 1 over omega C, XL equals to omega L, then I will assume you understand F is equals to 60 Hertz. All right. And then XC, if you got it right, J1, XL, you got it right, J1. Here, if you got the substitutions correct, G1, final answer with correct unit, JU1. So 5 marks for the calculations. Okay, 5 marks for the calculations. Next, questions 4. Questions 4, calculate the RMS current. Now a lot of you got it wrong. Why? Because you just simply use VIR. But now in these questions, you are having a RCL circuit. You are not looking at pure circuit. And the V given in the questions, the V equals to 156 volt. This is the total V across all 3 components. It is not just the V for resistor. So you cannot use VIR to calculate the current. Okay, you cannot just use VIR to solve the questions. So what are you going to do? Okay, you have a V maximum, questions 4. Your V peak is equals to 156 volt. Now you want to calculate RMS value. Of course, you need RMS voltage. So VRMS is equals to V peak over square root 2. Plug in the value and you should get 110.31 volt. That is for your VRMS. So once you have VRMS, you can then use it to calculate IRMS. VRMS is equals to IRMS times R. VIR. But then I told you cannot use RI. So in these questions, when it comes to chapter 6, you have to be extra careful. Since you have a combination circuit, therefore you need to change VIR into VIZ. So this is the most important part in chapter 6. All right. So quite a lot of you got it wrong because you use R in your calculations, right? So you need to use Z. So rearrange the equations. IRMS is equals to VRMS over Z. Plug in the value, your IRMS is equals to 2.11 ampere. So for these questions, if you got the VRMS correct, you got J1, and then final answer with the right unit, JU1, right? JU1. Okay, now questions 5. State the quantity measured by ammeter. A lot of you just write current, which is wrong. Because why? Because you have 2 types of current in these questions. Now actually you got 3. You got instantaneous current, you got the root mean square currents, and then you also got the peak current. Okay, so the things measured by this ammeter is actually your IRMS, root mean square current, your effective value. Okay, this A shows you the effective value, IRMS. Okay, the root mean square current. So is the circuit resonance justify your answer? Now you look at the question, it asks you to justify your answer. Means that you need to explain why. What makes you think so? If you say it is resonance, why? If you say it is not resonance, why? So you need to tell the examiner why. So how to answer question 6? Now to answer question 6, you need to think, what does it mean by resonance? What is the characteristic of a circuit if it is in resonance? So when your circuit is resonance, your XC would be equals to XL. But if you look at these questions, XC is equals to 75.79 ohm, XL is equals to 24.5 ohm. Apparently, they are not equal. Therefore, for question 6, okay, for question 6, the circuit is not resonant. Okay, not resonant. Why? Justify your answer. Because, okay, because your XC is not equals to XL. That's it. So if you got it right, then you got 1 mark for the not resonance. The terms know itself. And then XC not equals to XL. If you got it right, you got another 1 mark. That is the marks allocated in the question number 6. All right, question 6. Very simple. You just answer yes or no. Even if you don't know the answer, you can guess right. You can guess yes, it is resonant. No, it is not resonance. At least you try. Don't leave it blank. Quite a lot of you skip questions 5 for an unknown reason. I also don't know why. In fact, it is quite easy. It's quite simple. All right. So that is the answer for questions 6. Questions 5. Sorry, questions 5, chapter 6. So now we're done with this question. Let us try another questions. Okay, let us move on to questions 6, chapter 7. Okay, so well, I give you 2 minutes to go through the answer first. Okay, to go through this answer. Make sure you understand. Oke, kamu boleh tengok dulu, tengok sekejap, bagi Anda 2 minit. Anda tengok-tengok sebelum kita bergerak ke soalan ke-6, chapter 7. All right, now let us continue. We've got 2 more questions to go. Okay, we've got 2 more questions to go. So chapter 7. Chapter 7, questions 1 is about mirror. Okay, so this chapter 7, this question 6, consists of 3 sub-questions, 1 sub-question from each subtopic. So question 6a, an object is placed in front of a concave mirror. The first keywords given is concave mirror with a 20 cm radius of curvature. So this 20 cm is R, not your focal length. So be extra careful with this value. This is R, but not F. The second keywords given in the question is a real image. Twice the size of the object is formed. At what distance is the object from the mirror? So it is twice the size of the object. So means now it's getting larger. It's magnified. So first, okay, what should we do right now? First thing, we need to determine whether this R is a positive or a negative value. How do I know whether this R is positive or negative? Well, questions give you the first keywords, concave mirror. So you have concave mirror. When it comes to concave mirror, R is a positive value. Okay, so your R is equals to positive 20 cm. The second keyword is real image. Why is it important to know whether the image is real or not? Now, if it is real, then you will have positive V. But that is not the purpose of the questions. In these questions, it gives you the magnification. It gives you the values of M, twice the size of the object. It tells you this M is equals to 2. But it doesn't tell you whether it is positive 2 or negative 2. So when you have a combo concave mirror, okay, when you have a concave mirror plus real image, then it will always give you inverted image. If it is real, then it's always inverted. So in this case, the M given, it should be -2 because of based on the informations given. Concave plus real always give you inverted image. So M is -2. So that is the information that we have right now. So it asks you to determine the distance of the object, which is U. So what is the values of the U? So by looking at these three informations, well, it seems like quite weird, right? There's no one equations that can be used to combine these three informations, to put these three pieces of information together. So try to recall, try to go through the list of formula again. Okay, when it comes to this case, it is always a good idea to go back to the list of formula. So you look at the list of formula for chapter 7. So in chapter 7, you have equation 66 until 70. So apparently, you are given R. From R, you can get F. So in these equations, you do have U, but then you don't have V, right? So try to look at equations for M. Now you have an equation with M, and it also comes with U. U is the values that we want to determine. So this is unknown. V is also unknown. So now we have two equations with two unknown. So which means this would be our choice. Okay, these two equations will be our choice of equations. So now let us try these two equations, because now we have two equations with two unknown, where U is unknown, V is also unknown. So let's see, how are we going to solve it? So first equation is 1 over F equals to 1 over U plus 1 over V. But then we don't have F, we have R. What is the relationship between R and F? Now we have R equals to, it should be R equals to F over 2. Yes, true. Sorry, 2 F equals to R over 2. Okay, F equals to R over 2. So it is equals to 10 cm. All right, so just now we don't have F, but don't worry because we have R. So from R, we are able to get the values for F. And then let's plug in the value and see what happened. So 1 over 10 equals to 1 over U plus 1 over V. Okay, done. That would be our first equations. Then let's look at the second equations. Second equations, we have M equals to -V over U. Given M is -2, so -2 equals to -V over U. Rearrange the equations, we now have V equals to 2U. So you see, it is very important to include the negative sign in your M, because you will have a positive V, okay? Because you will have a positive V. If you write M as a positive value, then in your substitution, V will become a negative value, which indicates that now you are having a virtual image if your V is negative. So it doesn't match with the information given, right? Because information tells you now you have a real image. When you have a real image, V should be negative. So kalau tadi kamu tak guna M sama dengan -2 dan kamu rearrange equations, you are going to get V equals to -2U, which then gives you a virtual image. So this is wrong, okay? This is wrong. So that's why it's very, very important to know this relationship. Concave plus real always give an inverted image. What does it mean by inverted? Inverted means you have negative M, okay? So now you have the second equation, okay? Equations 2V equals to 2U. So what you can do, now you sub equations 2, sub 2 into 1. So 1 over 10 is then equals to 1 over U plus 1 over 2U. Right? Rearrange the equations, you will then obtain U equals to 15 cm. So in these questions, if you got the F right, then you get 1 mark. Second mark is given if you know M is equal to -2. It means you got the right concept. It means you know when you have a real image, then it is always an inverted image. And then you substitute it into the equations, G1, and eventually the final answer equals to 15 cm JU1. So 4 marks for this question. Okay, 4 marks for these questions. Let's start from the first equations, and then second equations, and then you substitute second equations into first equations, and you will get a final answer. All right, that is your 6A. So now let's look at 6B. 6B, figure 4 shows a glass rod with a convex surface. So now you have a convex surface right here of radius of curvature 6 cm. So convex surface with radius of curvature 6 cm. Now, why is it important to know whether it is convex or concave towards our object? Once again, it's going to affect the sign convention. So in this case, you have a convex surface. So convex surface means your R, it is equal to a positive value, positive 6 cm at one end. The refractive index of the glass is 1.5. An object is located at 20 cm from the curved end. Determines the locations of the image. So in these questions 1, now when it comes to this type of questions, the reflections at the spherical surface, you have just one equation, which is N1 over U plus N2 over V equals to N2 minus N1 over R. You have to know which one is N1, which one is N2. So your object is located on the left-hand side. Therefore, in front of the spherical surface, this is your N1, behind this is your N2. All right, so given U is 20 cm, and then R, according to our analyzation just now, we got R equals to positive 6. So plug in the value 1 over 20. Now you can leave it in cm, but just make sure all these three U, V, and R, they have the same unit. Okay, you just need to make sure they all have the same unit. So 1 over 5V equals to 1.5 minus 1 over 6. Rearrange the equations, you will then get V equals to 45 cm. So in these questions, if you got the substitutions correct, G1, substitutions correct means it comes with all correct sign convention. Final answer with correct unit, JU1. Now let's look at questions 2. Questions 2, now you put this whole things in the water. Okay, you immerse it in the water. You put it in the water, which means now the N is no longer equals to 1. The surrounding of the glass is now filled with water, and the refractive index is 1.33. Right? So now it asks you to determine the location. So you are still going to use the same equation. N1 over U plus N2 over V equals to N2 minus N1 over R. Everything is still the same except N1. Because now N1 is no longer the air, but it is the water. So N1 is now 1.33 over U 20 cm plus N2, oops, N2 should be the glass, which is 1.5 over V equals to 1.5 minus 1.33 over 6. Rearrange the equations. Now you are going to get a negative value, which is negative 39.3 cm. So that is the locations of the object right now. But that is not the ends yet, because question asks you to state one characteristic based on the values to obtain. So by looking at the value, you got a negative V. So the easiest way to describe it is a virtual image. Okay, the image form is virtual. Okay, the image form is virtual. So if you mention virtual, then you get 1 mark. So this one, because you are using the same equation, so no more mark is given to the substitution. So just a final answer, JU1, and then virtual J1. Okay, virtual J1. So can you say now the image is inverted or upright? No, cannot. Why? Because you have a point object. So you can tell whether it is inverted or upright. And since you are looking at just a point, well, it is quite hard, and you didn't learn how to calculate its magnification. Therefore, you cannot say whether it is magnified, diminished, or same size as well. you can't say anything about it, okay, because you don't have the equations and it is not in your syllabus. The magnification for refractions at a spherical surface is not in your syllabus, so you cannot talk about it in terms of magnifications or diminish, okay, whether it's magnified or diminished. And then the positions, well, positions you can say, but usually when it comes to just one characteristic, we seldom use distance. Okay, sometimes they won't accept distance, they won't accept the position. So the best answer for this question is the virtual image. Okay, upright inverted tak boleh cakap. Magnify diminish tak tahu. Okay, kita pun tak tahu. And then location, okay, kalau dia cuma nak satu karakteristik, kadang-kadang dia tak terima location, dia tak terima position. So the only answer, the best answer is virtual. Okay, it's virtual. So that is your questions B. Now let's look at question C. Question C, now you have a lens, a biconvex lens. So this is your biconvex lens. A biconvex lens has a radius of curvature of 15 cm. Okay, so you are given just one R, meaning as both surface, they have the same R. The index of refractions, glass is a 1.5. Okay, the refractive index of the lens is 1.5. Calculate the focal length of the lens in the air. So how to calculate focal length of the lens? Well, you are not given the object distance, you are not given the image distance. So obviously 1 over f equals to 1 over u plus 1 over v is not your choice. So the other equations that can be used to calculate focal length is 1 over f equals to n2 over n1 minus 1, and then 1 over r1 minus 1 over r2. So n2 is the refractive index of the glass, n1 is the medium. Okay, it's the medium. So now let's plug in the value. So it is equals to 1.5 over 1, because now the surrounding is the air. It tells you now you put it in the air, minus 1. Okay, now 1 over r1 and 1 over r2. What should we do? Let's assume my object is on the left-hand side. This is my object. So this is my object. I'm going to assume the light ray is coming from left then. When it hits the first surface is convex towards my incident ray. Therefore, first surface, it should be positive value, positive 15. Second surface is concave towards my incident light ray. So my second surface R would be a negative value, negative 15 cm. So put it into the equations, 1 over positive 15 minus 1 over negative 15, right? So eventually you will get F equals to 15 cm. That is the answer for questions 1. So in these questions, if you got the substitutions correct, means you substitute with the correct sign convention, G1. Final answer with correct unit, JU1. So now you repeat the questions again, but now once again, you immerse it in the water with a refractive index 1.54. So let's do it again. 1 over F equals to N2 over N1 minus 1, 1 over R1 minus 1 over R2. Now the difference now is your N1, because N1 is the N medium. Now you put it in the water, so it is equals to 1.5 over 1.54 minus 1. Then the rest, they are still the same. 1 over 15 minus 1 over negative 15. So it is now equals to negative 288.75 cm. So when you immerse this lens in the water, you're going to get a negative focal length. Negative focal length, it tells you now this lens is a diverging lens, because it asks you to state the type of the lens. So how do I know it's converging or diverging? By looking at the sign convention. Negative means diverging lens. So these questions, once again, because you're using the same equations, the only difference is the N1. So substitution, no marks anymore. Only the final answer will be given 1 mark. And then you state the type of the lens, another 1 mark. So again, it's a 2 marks question, right? It's a 2 marks question. So that is your questions 6, chapter 7. All right, I give you 1 minute to go through the solutions. Okay, make sure you understand what is the difference between the number 1 and number 2 in both questions. One is in the air, and then the second one is you immerse it in the water. Okay, kamu rendamkan dia ke dalam air. Dan bila kamu rendam ke dalam air, image positions will change, the type of the lens will change. You see, initially positive is converging lens. Biconvex by right should be converging lens. But when you put it in the water, it becomes a diverging lens. All right? So all this, they will affect the type of the lens. Okay, so let us continue with question 7, the last questions in your quiz. So question 7 is coming from chapter 8. All right, so now let's see, how are we going to solve this question? Now, first of all, you have to remember that in chapter 8, we have 4 subtopics, where first subtopic is a young double slit, second subtopic is thin film, third subtopic is the diffraction, single slit diffraction, and the last one is diffraction grating. Once you are able to identify what is the object that you're looking at, what types of a effect that you're looking at, then you should be able to select the right equations. So for this question, okay, if you look at this question, the first things that you have to go through, you have to find is what type of experiment, what type of effect that you're looking at. So in these questions, you're looking at young double slit experiment, which is a double slit interference. So double slit interference is performed by using 589 nanometer light. That is your lambda. The distance between the slit and the screen is 2 meters. This is your capital letter D. The tan dark fringe is seen 7.26 mm from the central bright fringe. So this one is your Y. Okay, it gives you the distance from the slit until the dark fringe. The question is, what does it mean by tan dark fringe? Okay, so by looking at the experiment, the name of the experiment, young double slit experiment, you know that this is young double slit, the double slit interference. In double slit interference, tan dark fringe, it represents the 9th order dark fringe. So your n is equals to 9 based on the terms, based on the statement tan dark fringe. So that's why it's very important to identify whether you are looking at interference or you're looking at diffractions. In diffractions, tan dark fringe represents 10 order. In interference, tan dark fringe, it represents the 9th order. Okay, the 9th order of the interference. All right. So now that you have all this information, questions 1, calculate the distance between 2 slits. Distance between 2 slits is this small letter. Is this between 2 slits is this small letter D. So small letter D, and then now we have lambda, Y, N, and D. So how are you going to solve it? It's very simple. You just have to apply the equations. The equations for double slit interference, and then it is for dark fringe. So you want the interference for dark fringe, equation is Y equals to M plus half lambda D over, okay, over D. All right, so that is your equations. And the things that we're going to find out, we're going to calculate now is a small letter D. All right, it's a small letter D. Okay, this should be M. So Y given is 7.26 mm. Make sure to change everything into SI unit. So it's 7.2 times 10 to the power of negative 3 meter equals to, now M, we have 9. So 9 plus 1 over 2, lambda given 589 nanometer. So 589 times 10 to the power of negative 9. Capital letter D given is 2 over small letter d. All right, so if you rearrange the equations, you should get d equals to 1.54 times 10 to the power of negative 3 meter. So that is the answer for the first questions. And if you got the substitutions right, you got all values substitute correctly, especially the order, then you can get G1. And then if you got a final answer with correct unit, JU1, right? Now let's look at questions 2. Questions 2, I think in your class only 1 or 2 of you got it right, if I'm not mistaken. Calculate the numbers of dark fringe that can be seen on the screen. So how are we going to calculate the numbers of dark fringes that can be seen on the screen? We need to look at the path difference. So if you look at the diagram, the path difference, okay, for this small triangle. For this small triangle, we have a delta L right here. So we are going to form an equation based on this delta L. So in this case, according to the diagram, we have delta L equals to d sine theta. Now again, since you are looking at the numbers of dark fringes, therefore delta L now in double slit experiment in an interference pattern, delta L, if you want to get a dark fringe, then the path difference should be m plus half lambda. Not just m lambda, okay? Quite a lot of you gave me m lambda. This one, it should be m plus half lambda. So by combining these two equations, we then obtain d sine theta equals to m plus half lambda. All right, so that is the equations that we're going to use to solve the questions. Then how about the angles? We're not given the angle. Now, if you want to calculate the numbers of fringes that can be seen, then we need to find the maximum fringes that you can see on the screen. Okay, it's asking for the maximum amounts of fringes. In that case, sine theta need to be equals to maximum. Okay, it needs to be equals to maximum. Where we are going to assume angle is equals to 90 degrees. All right, so you want to see the numbers of fringes that can be seen on the screen, then we treat the theta equals to 90 degrees. So now that you got the equations, okay, what are we going to do? Okay, we're going to plug in the value. So given D, okay, from questions 1, D is 1.54 times 10 to the power of negative 3. And then we have sine 90 degree equals to, now order is the things that we don't know yet. So m plus 1 over 2, and then lambda given 589, and then 589 times 10 to the power of negative 9. That is your lambda. Okay, that is our lambda. So if you arrange the equations, then you should obtain m equals to 2614. Okay, 2614 order. So the numbers of fringes that can be seen, now remember order, well, order is always a one number less than the fringe. So what is the value in this case? So the numbers of fringes that can be seen, okay, numbers of dark fringe that can be seen is equals to, okay, since you are looking at dark fringe, okay, so if you have 2614 order, that it means you can see 2615 fringes on one side, because 9 order equals to 10 fringes. So 2614 order is 2615 fringes. So 2 times 2615. All right, because you have two sides. One is below central fringe and one is above central fringe. So in this case, the numbers of fringes that can be seen is equals to 5230 fringes. Okay, that is your answer. All right, that is your answer for questions 2. For questions 2. So the marks is given, okay, in this case, the mark is given if you know how to form these equations. All right, so this is your K1. And oops, and then in these questions, okay, in these questions, this is your substitution. You have a G1 right here. So at last, you got the JU1. All right, JU1. This is a 3 marks question. All right, this is a 3 marks question. So first mark is given to if you are able to form the equations. Second mark is given to the substitution. If you got all the substitutions correct, especially the angles, then yes, you got a 1 mark. And then the last one, you calculate the numbers of fringes. So the numbers of fringes that can be seen is 5230. The numbers of order that can be seen is 2614. So remember, one order equals to 2 fringes. Okay, first order equals to 2 fringes, and then second order 3 fringes. That's why when you have 2614 order, means you have 2615 fringes on one side. So total, the numbers of fringes that can be seen on the screen, above is 2615, below central bright fringe is another 2615. Altogether, 5230 fringes. What will happen to the interference pattern if the distance between the slit decrease? So it's asking what happens to the interference pattern if you change one of the variable. So when you are talking about a change in the interference pattern, then we often refers to delta y. Delta y equals to lambda d over d. Now you change the distance between slit. You change the small letter d. So let's see what is the relationship between delta y and d. So apparently they are inversely proportional. So if they're inversely proportional, it means that when d decrease, delta y increase. So therefore, okay, therefore we say the fringes becomes wider. Okay, the fringe becomes wider. So the keyword is it becomes wider, or you can say they becomes larger, also can. So the mark is given to if you understand the relationship between delta y and d. So you got K1, and then if you mention wider, larger, or the distance between the slit becomes longer, also can. Then you get the 1 mark. Okay, J1. So altogether 7 marks for this question 7A. All right, for question 7A, we got 7 marks. So now let's look at questions B. How are we going to solve questions B? So questions B is just a very short question. Okay, but even though the question is short, but if you look at the marks allocated in this question, it's 5 marks. Means definitely you're going to use at least 2 equations to solve it, not just 1. Because 1 equations, usually you won't have 5 marks, right? So how are we going to solve these questions? A monochromatic light is illuminated to a diffraction grating. So which has a 5310 lines per cm. Okay, 5310 lines per cm. The second order maximum produced by the diffraction angle, by the diffraction grating, is at an angle of 35 degrees. So this one, it tells you the angle is 35 degrees, and it didn't mention where is it right now. Where is it right? Well, if you look at this question, it is happening at an angle 35 degrees. So it is at an angle 35 degrees above where? So it's above the central fringe. So therefore, this is the complete angles that we're going to use. Okay, don't divide by 2. When I go through your script, some of you divide by 2, which is wrong. Now, you have to divide by 2 if it tells you this 35 degree is between 2 second order maximum. But now it just say it is at an angle 35. So at an angle 35 degree usually is at an angle above a horizontal line. All right. So in this case, this is your theta. All right, this is your theta. You don't divide by 2. Okay, I saw that some of you divide by 2. Okay, because I agree that there's a bit of a lack of information in the questions, but then it didn't say it's between 2 second order. So don't divide by 2. So you are given capital letter N, you are given the angles. Questions ask you to calculate the numbers of maxima that can be seen on the screen. If you look at these questions, you don't have the enough information. You don't have the lambda. Okay, you don't have the lambda for you to calculate the number of fringes that can be seen. Even though if you want to calculate the numbers of order can be seen, you know that the angle is 90 degrees, but then you don't have the wavelength. So what we can do right here, if you look at the question, now it tells you second order maxima is produced at an angle 35 degrees. So when it comes to this case, you do have the n equals to 2. Okay, so what we can do, we can apply the equations for diffraction grating, which is d sine theta equals to n lambda, to solve the questions, to determine the wavelength first, before you use it to calculate the numbers of order that can be seen on the screen, the numbers of maxima that can be seen on the screen. So the first step, you apply these equations to calculate the wavelength. But then we don't have d, right? However, what we do know is d is equals to 1 over n, right? D is equals to 1 over n. And n we have right here is 5310 lines per cm, okay, per cm. So what are you going to do? Well, let's change it to meter first. How to change n into meter? N equals to 5310 line per cm. If you write it in fraction form, it is equals to 5310 lines over 1 cm. So it is then equals to 5310 lines over 1 times 10 to the power of negative 2 meter. So it is then equals to 5.31 lines, 5.31 times 10 to the power of negative 5 lines per meter. So now you have n in terms of meter. Okay, you have n in terms of meter, then you should be able to calculate d. Now, of course, you can write 1 over m into the original equations, where we have 1 over n sine theta equals to n lambda. That is how you can write it in your exam. Okay, you don't have to calculate d first. You can straight away use 1 over n in your equation by substituting d equals to 1 over n. Okay, that is accepted in your exam. So in this case, what we have right now is 1 over 5.31 times 10 to the power of negative 5 times sine 35 degree. Okay, why? Because this 35 degree belongs to this second order. So you need to look at the angle and the order, see which one is coming from the same family. So 35 degree belongs to second order. All right, so that's why you cannot use second order to calculate the number of fringes that can be seen on the screen. That is a mistake that some of you did in your test. So times lambda. Rearrange the equations, you will then obtain lambda equals to 540 times 10 to the power of negative 9 meter. So that is your first step. You determine the wavelength from the information given from the second order maxima. And after that, you then calculate the numbers of order that can be seen on the screen. Okay, before you calculate the numbers of maxima that can be seen. So you need the numbers of order that can be seen. So maximum numbers of order, okay, maximum value for maximum. Sine theta is equals to 1. Okay, or you can say theta is equals to 90 degree. So what are you going to do in this step? Well, you're just going to apply the same equation. D sine theta equals to n lambda. And then we have 1 over m sine 90 degree equals to n lambda. Okay, so substitute the value into the equations. 1 over 5.31 times 10 to the power of negative 5. Sorry, not negative 5. It should be 5. Right? It should be 5. My bad. So times 10 to the power of 5. And then sine 90 degree is equals to 1. So you don't have to write it anymore. And then n times the wavelength from the previous step. 540 times 10 to the power of negative 9. So now this number of order that you are going to calculate, it belongs to 90 degree. All right, so that is what I mentioned just now. You have to make sure the angles and the numbers of order, they are coming from the same family. So 35 degree belongs to second order, and then 90 degree belongs to the numbers of order that I'm going to calculate now. So now I have n right here. If I rearrange the equations, I will get n equals to 3.49. When it comes to chapter 8, okay, you need to round up the value. So it is approximately equals to 3 order. Okay, you have 3 ordered. So as long as it hasn't reached 4, even if you have 3.9, then you take n as 3. Okay, but that is not the n's yet. This is the numbers of order. Now the question is asking for numbers of maxima, which is the bright fringe. The maxima that can be seen. Okay, that can be seen. So which is equals to 2n plus 1. Why plus 1? Because this one, it belongs to central bright fringe, your central maxima. So therefore, the total fringes that can be seen on the screen is 7 fringes. All right, it's 7 fringes. Not 3, not 4, but 7. Because you can see 3 above and 3 below. Okay, 3 above the central fringe, 3 below the central fringe, plus 1 central fringe. So you have 7 bright fringe on the screen. All right, so that is how you solve questions B. And then the marks is given first if you substitute the 35 degree with 2 in the same equation. All right, you substitute 35 degree and 2 in the same equations. And then if you got the wavelength, J1, and then the third mark is given to the second substitution where you know angle is 90 degree when you want to calculate N. And then you got 3, that is another J1. And final answer is 7. So you got the JU1 right here. So that is how you answer questions 7B. Okay, that is how you answer question 7B. So 5 marks together. Okay, 5 marks all together. So that marks the ends of the quiz. Okay, that marks the ends of the all 7 questions in our quiz.